MapReduce. Amazon EMR Cluster provides a managed Hadoop framework that makes it easy, fast, and cost-effective to process vast amounts of data across dynamically scalable Amazon EC2 instances. We can also run other popular distributed frameworks such as Apache Spark and HBase in Amazon EMR, and interact with data in other AWS data stores such as Amazon S3 and Amazon DynamoDB. In this lecture, we're going to run Spark application on top of the Hadoop cluster, and we'll put the input data source into the S3. In case you don't know, S3 stands for Amazon Simple Storage Service. S3 is a distributed storage system and AWS equivalent to HDFS. You might want to ask why we need to save our input source file into S3 instead of local disk. This is because in the real world, we want to make sure that our data is coming from some distributed file system that can be accessed by every node on our Spark cluster. That could be HDFS file system on the Hadoop cluster or S3. But we want to make sure that our Spark application doesn't assume that our input data sits somewhere on our local disk, because that will not scale. Imagine in reality, you might have a terabyte scale of data to process. They can't fit into a single hard drive. Even if they can't be accessed by all the Spark nodes deployed on different machines. By saving our input data source into S3, each Spark node deployed on the EMR cluster can read the input data source from S3. Just a reminder here, AWS is not free. AWS charges by how much time and how many machines are running with a given type, any storage space, etc. We paid for what we use. It cost me about $30 setting up and running the demo stack for about 4 hours on AWS. I recommend you only watching me in this lecture. If you want to follow along, make sure you terminate your cluster and delete your files from S3 after you're done. Let's get started. Here I'm at the AWS landing page. To deploy an EMR cluster, you would need to have an AWS account. In case you don't have one, just go ahead and register one. I already have an AWS account, so I click Sign In to the console to log into the AWS Management Console. Then click Services on the top left. Select EMR. Now we're at the EMR page. Click Create Cluster. We leave the cluster name as default My Cluster. All the logging of this cluster will be automatically saved to S3 for future retrieval. There are two launch modes. With cluster mode, EMR will create a cluster with a set of specified applications. You can add steps to the cluster after it's launched, and the cluster continues running until you terminate it. With step execution, EMR will create a cluster, execute added steps, and terminate when done. The steps that you add determine the applications that are included in the cluster. When your cluster launches and the steps complete, the cluster is automatically terminated. We want to install Spark on top of the Hadoop cluster, and we don't want the cluster to terminate automatically after the job is done. So we choose the cluster mode. This vendor option specifies the vendor from which you want to select the software release and applications for your cluster. We choose Amazon. This release option specifies the software and Amazon EMR platform components to install on the cluster. Amazon EMR uses the release to initialize the Amazon EC2 instances on which your cluster runs. The latest release label is selected by default. We leave it as default. The application option determines the applications to install on your cluster. Here we want to install Spark on top of it. The Instant Type option determines the Amazon EC2 instance type that Amazon EMR initializes for the instances that run in your cluster. We use the default m3.xlarge instance which has 4 CPUs and 15 GB memory. The number of instance option determines the number of Amazon EC2 instances to initialize. Each instance corresponds to a node in the Amazon EMR cluster. Here we'll initialize 1 master node and 2 worker node. The EC2 key pair option specifies the Amazon EC2 key pair to use when connecting to the nodes in your cluster using SSH. If we do not select the key pair, you cannot connect to the cluster. I have already created several ECD key pairs, so I pick one of them from the list. If you haven't created one yet, just follow the link to create one. For the rest of the permissions, we go with the default options. Then we click Create Cluster to start the provisioning. Now, as you see, the cluster is in starting state, which means the cluster is being provisioned. This process takes about 10 to 15 minutes to complete. After the cluster is successfully created, the state will turn from starting to waiting. Next, we'll need to update the security setting so that we'll be able to access the Spark cluster from our local machine via SSH. Here we click the link for security groups for the master. Then select the second entry for the master group. Make sure you select the master one, not the slave one. Then click Inbound Type. Edit. Click Add Rule. In the Custom TCP Rule column, we select SSH. In the Source column, we select Everywhere. What this means is that we're going to create a new rule to allow us to SSH into the master box from everywhere as long as the private key is present. This is not recommended settings for production. In production, you should restrict which IPs can access your cluster. Here we choose Everywhere as the source just for the sake of simplicity, but don't do this in production. Then click Save to save the new rule. Next, let's prepare our input data source. The Stack Overflow survey data source we analyzed on our local box is only 2 megabytes, and it is a subset of the full Stack Overflow survey data source. Now, since we're going to run our Spark application on a much larger cluster on AWS, we can analyze the full Stack Overflow server data source this time. Here I'm at the Stack Overflow research page. We can download the full data source from here. After the download is complete, let's untar it. As you see, the full Stack Overflow server data source is in CSV format and is about 70 megabytes. Next, we'll be uploading this file to S3. One restriction about S3 is that it doesn't allow the file name to contain spaces. So here we rename the CSV file to remove all the spaces. Then we log in into the AWS Management Console again. Click Services on the top left. Select S3. Let's create a new S3 bucket for our Spark job. A bucket is a logical unit of storage in S3. Objects are created under buckets. Here, we name our S3 bucket Stack Overflow-Analytics. Then click Create. Just select the newly created bucket name. Then click Upload. Select Add Files. Choose the Stack Overflow server file. After the uploading is complete, we can see the CSV file appears under the bucket. Next, we need to make some changes to the source code of our Spark application. Let's open the Stack Overflow server file under the Spark SQL package. When we run our Spark application on Elastic MapReduce cluster, Spark cluster will know how many nodes are available and where is the master machine, so that cluster will provide a sensible setting at runtime. If we supply any settings here, they will override the cluster configuration. In our case, our setting is to run in local mode, so Spark will just run our application only on one machine. Make sure we remove the master option here when we create the Spark session. The only thing I'm going to set is the application name. The application will get the rest of the setting from the EMR cluster at runtime. The other change we need to make is to replace the input file path to S3 path so that each Spark cluster will load the file from S3. The S3 path format is S3 n column / bucket name / file name. Now we can go ahead to rebuild our jar file. Just run the clean task to remove the existing jar and call jar task to regenerate a new one. Verify the new jar file is generated under the build/libs directory. Next, let's upload our jar file to S3 as well. Click the bucket name and click Upload to select our jar file to upload. Now we have our Spark jar file and input data source ready on S3. Let's log in into the Spark master machine via SSH. Click the SSH link under our cluster page. If you're running Windows, just click the Windows tab. Then follow the instruction to SSH into the master machine. You will need to install PuTTY. Since I'm using a Mac machine, I click Mac and Linux tab. Then copy the SSH command and paste it into a terminal. Make sure there is an EC2 private key file at the path to the private key file. If not, you will need to update the path to the point to the right location. Then hit Enter to SSH into the host. Now we're inside the master machine of the EMR cluster. Let's fetch the jar file from S3 to the master machine here for execution. We run AWS S3cp command, which can copy files from or to S3. Then supply the source file path, which is the S3 file path. The format is S3 column / bucket name / file name. We supply the destination path, which is current directory, so just put a $sign here. Hit Enter to start fetching the file from S3. After the jar file is downloaded, we can submit the jar file to the Spark EMR cluster. By default, the Spark submit script is included to the Linux path environment variable now. So we can just run Spark submit and put the jar file name as argument, and hit Enter to run our Spark job. See, we get all the job outputs. Now we have seen how to run our Spark application on a remote cluster. Make sure you delete all the files from S3 and terminate your EMR cluster if you don't